I got a batch of brass that I'm working up, and I need to fire form a bunch of it. So instead of just cutting rounds off into the hill somewhere, I figured I may as well try to figure something out. So what I'm going to do is get the gun right on the money at 100 up in the hills up here, as you can see. I'm going to get it zeroed at 100, and then I'm going to put a target down slope. We'll see how many degrees we should be able to get, maybe 4 degrees downhill or so, and then I might be able to pull it off, getting that same slope going uphill with a safe backstop. And we'll see how much of a difference it makes at 200 yards for up and down after it's been zeroed at 100. So I'm going to verify my zero. Okay, there's my target. I have checked it with my Leupold rangefinder, and we are 100 yards away exactly, and 0 degrees of a rise up or down. So I put some rounds on it, verify my zero. The load that I used for fire forming this brass, not wanting to waste good match bullets, these are 174 grain pulled Lake City full metal jacket. The 3-shot group you can see in the upper third of the plate there, no load development at all. That was probably, it looks like maybe about 2-inch group, and a couple inches high. I corrected to the left and then held right at the base of the plate, and as you can see there's the hit at the base, about, once again, 1.5 to 2 inches up. I'll verify what that is before we do anything else. And I've run out of adjustment down on the scope, so we're going to just have to take into consideration that we are that measurement high. I'll get exactly what that is, and we can use that info later. Here's that target up close, for not doing any load development, just shooting those pulled bullets, trying to get the brass fire formed. 3 shots with not a real solid rest. That was a 2-inch group, and from center of the plate, that is 1.5 inches, 2 inches high. And after the correction to the left, you can see there it is 1.5 inches high, so we'll take that into consideration later. Over the winter I changed the rings on the scope, and I had already had the zero stop set, so in attempting to come down any more, I was unable to. So without tearing the scope apart right now, we're just going to do this knowing that it is hitting 1.5 inches high on the level at 100 yards. Here we are up on the hill. I have 200 yards to that target that you can see right there, and according to my rangefinder, that is 10 degrees down. So we're going to take the shots from right here and let's see what 10 degrees does. I've got a mark in the middle of that 30-inch tall plate, and then we'll switch it around and shoot up the hill. Okay, downhill 10 degrees, put 3 rounds on target. Looks like 2 right in one spot. Remember, it was 1.5 inches high at 100. We'll go check that out, switch it around. Well, here's our target. With a 10-degree downward slope, I really was expecting something different. I'm pretty sure, as you probably saw in the video, I think it was one hit, another hit, and then the other hit. 1.5 inches high at 100, and here at 200, I don't know, it might still be the same. It's kind of a big aiming area, but it's still, I don't know, 1 inch high. Interesting. With going downhill such a number of degrees, I figured that it would be even higher. But let's shoot up the hill and see what we get. Now here we are 200 yards up the hill. Because of my need for safe backstop, I have the plate down the hill a little bit, and unfortunately we only have a 7-degree up the hill shot. So, well, let's see what happens. Okay, 3 rounds. Well, I find that very interesting. I can't believe how little of a difference it made. But we'll look at the plate up close and see what we've got. For being 1.5 inches high at 100, right on the money, like these two, you know, it's really not that far off from where you would expect it to be on the flat at 200. This was 7 degrees uphill. I don't know, 1.5 inches high at 100, and it just it dropped in about where it should be. We'll have to look at some ballistic charts and see what they think it would have been doing. I'll get the velocity and so on, see what we've got going on. I looked up that ammo. It's actually M118 Full Metal Jacket, 174 grain stuff. The ballistic coefficient is .494. I chronoed a few of them, and I'm getting 2433. I printed one sheet off on the flat, and then down our 10 degrees, and then our up 7 degrees. So I had to put the 0 at 165 to get our trajectory to be up the 1.6 inches at 100. So with that data, when you shoot 200 yards down 10 degrees, it should be 2 inches low. Well, as you can see right there, that is not 2 inches low. And if you're watching the video, all 3 rounds are actually in here. This paint keeps chipping off each time a shot is taken. So, well, let's see what it does when we go uphill. Now, shooting uphill, once again, 1.6 inches high at 100. At 200, it should be 2 inches low. And that is the uphill group right there. That is up 7 degrees. And I don't know, maybe it might be an inch. Well, there's 2 right there actually. So that's pretty close anyway to what Hornady believes should be going on here. So the conclusion that I've come up with these 174 grain M118 Lake City bullets here is going by Hornady's charts here. My results were that it was less. It was less of an effect on the drop or rise going up or downhill. I did one with it on the flat, then our 7 degrees up and our 10 degrees down. And what I want to point out is supposedly on the flat it's going to drop 109.7 inches. And my concern was always over at Vernon. Oh geez, we're shooting uphill 5 degrees at 600. Here's 600. This is actually 10 degrees up, and it's 0.8 of an inch difference for 7 degrees up. I mean, that shows that it makes almost no difference at all for some reason. And I mean, that's actually going by these charts. Now, see, this is 10 degrees down, and it's 2.5 inches different from the flat. But what my point is that in reality, I got less than what these charts were showing. And so that's I'm pleased with shooting over at Vernon over there. Then if that's not going to be a big deal, because then I know I can go someplace where it's flat, and it's not going to make, because I expected it to be half a foot or more actually, with the 5 degrees off over there at that range, 600 yards. I'll stop rambling now. Thanks for watching. See you later. I needed to try this out with a different round, different gun, and see if the results were the same. So here's Jasmine's 243, shooting the 105 grain AMAX. It's been pretty accurate. I didn't have a real solid base up there, but anyway, at 100 yards I took a sighter, because I also improved her scope over the winter, so it was not zeroed. Made an adjustment and then shot 2, so that's pretty much height-wise on at 100. Now, going up the hill 7 degrees, there's the group. I measured it. It's approximately 2¼ inches low. Well, Hornady says that it should be 3.5 inches low. And then when we went down the hill, once again, the average of these three is approximately 2¼ inches low. And Hornady says 3.4 inches low. So still, I'm getting less of change than what the charts are dictating. So I guess the takeaway from this is that even over 17 degrees of variation, 10 down and 7 up, the drop is almost identical. And it's also less than what Hornady's calculator is expecting it to be. So there we go.